Hi, my name is John Goldsmith, and this is the second and final part of a short course on Visio for developers. If you've not watched the first module, I'd really encourage you to do that, as it covers a lot of the structure and functionality that you'll be writing code against in this module. One of the things that makes Visio so powerful is the very substantial API that sits behind it. By substantial, I mean both in breadth and depth. You can code against Visio from a number of different languages, which range from VBA through C# and C++. So I'm going to start this module by looking at what those choices are and how you go about deciding which ones to use. Once we've looked at the choices, I'm going to take a tour of the object model and call out the significant parts of Visio and see how they connect together. I'll then move on to the event handling in Visio, again looking at the multiple options that are available there, and finally finish the module by considering how you go about deploying your solution's code, stencils and template to the end user's machine. As I mentioned in part 1, I wanted this course to give you a really good overview of the fundamentals of Visio development, and there are a few areas that I don't think fit into this category, but for completeness I'll mention the ones that I'm not going to cover. Firstly, there's Visio Services. This is a feature of SharePoint, both on-prem and online, and operates as a service just like Excel services. It's only available in the enterprise version of SharePoint Server and with an E3 or above subscription for its online counterpart. Visio Services is worthy of a separate course and outside the scope of this course, which is about understanding Visio fundamentals. Just like the rest of Office, Visio uses an open packaging file format, which can be unpacked to expose the document in the form of XML. While the packaging aspects will be familiar to you if you've done work on Word, Excel or PowerPoint files, the contained XML schemas might not be. The SDK has some worked examples, though, of how to build Visio files outside of the application, and schemas are also available to help you along the way. In addition to the main application, Microsoft also makes a viewer available for Visio documents. Again, the SDK provides documentation on how you can extend and wrap this functionality into your own solutions if surfacing a document in a read-only manner is required. So let's dive in and have a look at what the choices are when trying to extend Visio. When it comes to extending your Visio solution with code in the desktop client, you have a number of choices. These can be seen as three main technologies, all of which have a number of variations. There's VBA, add-ons and add-ins. While these three represent the standard choices, I'm also going to briefly mention two other options, the Visio Drawing Control and PowerShell. But first of all, let's get started with VBA. Visio was an early adopter of VBA, reaching back prior to it being bought by Microsoft. The language is the same as that found in Excel, Word and PowerPoint, the main difference being the object model, which we'll have a look at in a moment. Another important difference is where you choose to store your code. Unlike Excel and Word, which can store code centrally in a special workbook or template, Visio has no such single file. One option might be to place your code in a template document, which would give you access in all drawing documents that are created from it. This, of course, would result in multiple copies of the same code, which is clearly not a great situation. A better choice is to house your code in a stencil document. Because open stencils are recorded in the workspace information of a template, the same stencils will be opened up with every new drawing based on that template, and with it, your code. VBA is still great for prototyping and for solutions where you have a fairly small number of users, but if you want to distribute your solution more widely or benefit from the richer features found in other languages and frameworks, then add-ons and add-ins will fill this gap. Add-ons allow you to write application-wide functionality, and a good deal of the additional features that appear in Visio, such as the org chart wizard, the brainstorming tool, and cross-functional flowchart are included using just this method. Add-ons can be implemented in one of two ways, as a VSL file or as an exe. The VSL or Visio Solution Library, which is really a DLL with a different file extension, can house multiple add-ons, and since it's a DLL, runs in the same process as Visio. A VSL exports a single entry point, named Visio lib main, and Visio uses this to send your VSL a range of messages, such as to query what add-ons your VSL contains, to determine whether a particular add-on is enabled or not, or most importantly, to run an add-on. Although VSLs tend to be written in C++, they can be implemented in any language that can create a DLL and export an entry point. You can also implement an add-on as an exe. This can be written in any language that supports automation, and in contrast to VSLs, runs in a separate process. A main benefit of being in a separate process is that the code can continue to run both before and after Visio shuts down. The downside, of course, is that you pay a performance hit for all those cross-process calls. Alongside add-ons sit add-ins. The ones I'm talking about here, by the way, are the classic COM-based add-ins, and not to be confused with the more recently named Office add-ins, which are HTML and JavaScript based. So, as per the rest of Office, add-ins come in three main flavours, all of which run in process with Visio. There's COM add-ins, shared add-ins, and Visto or Visual Studio Tools for Office add-ins. COM and shared add-ins both implement the IDT Extensibility 2 interface, which via methods such as on-connection and disconnection forms the basis of communication between Visio and the target add-in. COM add-ins are created using unmanaged code such as VB6 or C++, while shared add-ins allow code to be written in managed .NET code. Shared add-ins suffer from two main issues. Firstly, multiple add-ins are placed into the same default app domain. This means that if another add-in generates an unhandled exception, it can bring down all other add-ins in the same app domain. Second is the inability to sign your code, and so face the prospect of your add-in not loading when the user's security level is set to high. This is due to MS Core E DLL, which houses the CLR and so COM interop, needing to be loaded and registered prior to your managed DLL. You obviously can't sign the MS Core E DLL, but that's what Visio sees as the primary assembly. This was really an Office-wide issue, and both of these problems were solved with the introduction of a COM shim, which wrapped your code, allowing you to sign it correctly, and also loading it into a separate app domain. While the shim dealt with the problem, it was both somewhat involved to create and also not officially supported by Microsoft. So finally Visto add-ins were introduced, which included a similar built-in shim in the form of the Visto loader, dealing with the issues of isolation, security, and ease of implementation. Before I look at how to choose one of the three main extensibility options, I'd like to quickly mention two other methods of interacting with Visio. The first is the Visio drawing control. This is an ActiveX control that wraps the Visio type library and allows you to host the Visio drawing surface within your own application, such as a Windows form, a WPF application, or indeed another Office app. The control is essentially full Visio with a couple of caveats. Since it's a single document interface, you can only load one document at a time, and also that it will not execute any VBA that may be present in the document. There's a sample Windows form application in the SDK, and I'll run that up now. You can see that we've got three buttons that correspond to three masters in a hidden stencil. The control has a source property that allows you to open one drawing document at a time, but you're free to open other stencils as required. If I hit the buttons, you can see that you can then interact with those shapes, just as you would with Visio, and it's up to you how much of the chrome and the various shape handles you want to make visible. This is a great application. I really encourage you to have a poke around, as it covers reading data, dropping shapes, and interrogating the drawing for the current layout. So that's wrapping up Visio into a control that can live in your own application. The second technology I'd like to talk about is PowerShell. Since PowerShell is able to create and interact with COM objects, you're free to talk to Visio as you would with any other COM application like Excel or IE. So as an example, I put together a simple demo script that interrogates a SharePoint Online tenant and then draws out the structure of the site collections and web objects that it discovers. All of the talking to SharePoint Online is dealt with courtesy of the Office Patterns and Practices PowerShell commandlets, and demonstrates one of the main benefits of using PowerShell with Visio, and that's PowerShell's extensive library of commandlets that allows you to automate on-prem infrastructure through to cloud platforms such as Office 365 and Azure. So let's look at it in action. Here's a single script, and behind the scenes I've put together a quick class using the class functionality that's now available in PowerShell 5. You can see from this image that the class has a number of methods that allow you to drop instances of masters on the page, either as a standalone shape or as the hierarchical child of another shape. The class keeps a little bit of state, both in terms of the current shape that it's focused on and a collection of masters that can span multiple stencils. The patterns and practices part deals with iterating through the site collections and webs that live underneath each one. The whole thing is kicked off by the new online tenant diagram commandlet. And you can see that I start off by newing up an instance of that class and passing in a template name which is already registered in Visio. I then drop a shape for the top level tenant, set its shape data, and then loop through all of the site collection properties within the site collection. And from there I recursively loop through all of the web objects and drop a shape and assign the shape data for each one. Let's actually run it and see what happens. I pass in the admin URL for the tenant that I'm after, and also the named credentials that I've added as a generic credentials in Windows. If I zoom in a little bit and select the shape data window, you can see that I've assigned a few properties to this web object, but it's up to you what properties you want to surface on the shape and ultimately report on. So with a few lines of PowerShell code, I've been able to put together a tool that's ultimately flexible, allowing you to choose which properties and objects to surface visually to communicate and monitor your own platform. If you do use PowerShell on a regular basis, there's a great open source project called Visio PowerShell that's really worth looking into. The project was created by a Microsoft employee called Savine Reddy, who's done some amazing work wrapping up some of the more laborious and tricky parts of interacting with Visio via PowerShell. So returning to the main options, how do you go about choosing which one to develop your solution? Aside from the particular language skills that you or your team may have at your disposal, each option offers a number of benefits. VBA is easy to write and fast to access. I'll often prototype something in VBA before converting to C#, which I guess I'm most comfortable in. If you have a very small number of end users, or those users are able to add and extend code themselves, then VBA can be both a flexible and accessible choice. Beyond a small number of users, however, VBA becomes more challenging to distribute and importantly maintain, and this is where you might want to look at some of the add-in options. In most cases, I would say that Visto add-ins are the way to go. However, shared COM add-ins do have the advantage of working across multiple Office applications, where Visto is generally app-specific. So if you need to address more than one application, then shared COM add-ins is something you should consider. Moving on to add-ons, the distinction between this and add-ins used to be more significant. Only add-ons could be called directly from the shapesheet or using persistent events. For example, you could include the run add-on shapesheet function within formulas in your shapes, but historically there was no equivalent for add-ins. This changed in 2003 with the introduction of a new helper add-on called the QMarker event add-on that allowed you to address add-ins by queuing a marker event on the application object, and then listening for that event in your add-ins code. I'm going to look at events in Visio later in the module, but for our comparison here, the upshot is that the choice these days is probably more about your preferred language rather than any very significant differences in functionality. There is, of course, a difference between VSL add-ons which run in process and exe-based add-ons which run out of process. If you need code to run either before Visio starts or after it stops, then an exe add-on might be something to think about. On the one hand, it may seem an attractive option. You create a simple WinForm or WPF app and just wait to be invoked with an argument string that tells you the document, page and shape IDs that fired the event. However, the exe route carries a number of caveats. For example, your exe only gets passed an argument string and has no direct knowledge of the application that sent it. It's up to you to find the running app and to check that it's the instance that you think it is. If the user invokes the add-on a second time, then a new instance of your exe is generated, and so you might also want to implement a strategy for handling those multiple instances in your program. The long and the short of this is that exe add-ons tend to be used for wizard-like scenarios, often supporting first-time configuration for a particular template, or modeless monitoring tools that stay open throughout and beyond the life of the Visio application instance. The drawing control clearly lends itself to those scenarios where you need to embed the Visio drawing surface into your own application. It allows you to include all of the shape handles and control elements for your users, but to restrict the full UI that may be over and above what's required for a focused single-tasked application. The final part is PowerShell. This obviously makes sense if you're already using it to access a target system. It provides a way to add visual reporting to PowerShell, but also to read from existing diagrams. So now you know the broad spectrum of choices, I'm going to move on to look at the object model, as this is really the core of the application. Visio exposes an object model that follows a similar pattern to other Office applications. As you might imagine, it all starts with the application object. This holds a collection which contains 0 or more document objects. A document has a collection of 1 or more page objects, and a page has a collection of shape objects. Each shape has its own shapes collection, representing the subshapes within a group. Aside from the subshapes, this is where the collection object pattern stops. However, conceptually you can still think of a shape as containing a series of shapesheet sections. Each section contains a series of rows, and each row contains a series of cells. Although there are section, row, and cell objects, you'll generally use shape properties to access the cells. There are two ways of doing this, by name and by position. For example, to access the formula of the fill foreground cell by name, you'd use shape.cellsView and fill foreground cell name. And to access the same cell by position, you'd use the section row column syntax, or cells src property, passing in the correct enum values. If you want to find out the name or enum values for a particular cell, then just crack open the SDK and look up the respective cell reference, where you'll find all the details you need. So although there are getting on for another 80 or so objects, the primary ones to understand are application, document, page, shape, and cell. Beyond that, I'll call out a few other significant ones, just so you know where they live in the hierarchy. Anything to do with selection and view are handled by the window object, which itself contains a property which returns a selection object. You can use the active window selection to get hold of the currently selected shapes, and then add and remove items from that selection using associated methods on the object. The location of the data record set object, which I talked about in the previous module, and the validation object highlight the document-centric nature of these two features. And finally, you can see the layers collection sits instead at page level. So that's the basic object model. Let's take a look at a quick demo to show how you go about dropping shapes, and most importantly how you write to cells in those shapes to set their appearance. Here's a coffee store layout. This diagram has a number of shapes, including 2 custom shapes that I've put together and housed in a stencil named Coffee Store. The stencil is also home to some supporting code that enables the user to right-click on a table shape and add a chair. As you can see, as the chair's added, both the new and existing chairs are arranged around the table. To achieve this, I've added an action or a context menu item to the table shape. This uses a callThisShapesheet function that enables you to invoke VBA code in an associated document. It includes the method and document identifying where the code can be found. In this case, it's the addChair method. The callThisShapesheet function expects a public method that takes a shape argument, which Visio passes in, when it's invoked, and that gives you a reference to the specific table instance shape. From there, we can do a quick spatial search to create a selection object that includes all of the chair shapes that are either contained by or overlap the table shape. Once you've got the selection of the existing chairs, you can use the drop method on the page object to add a new instance of the chair master and add it to the selection. Now that all the chairs are present, you can finally arrange them using polar coordinates around the target table. While I don't want to spend too long on the individual lines of code, as you look through the two main methods, notice the places where we're reading and writing to the formula property of the individually named cells. This highlights the fact that cells are at the very heart of how Visio operates. For example, at first sight you might expect the shape object to have a width and height properties that you could access directly, but that's not the case. While the shape object does have a number of direct properties, broadly anything to do with the shape's appearance can be found in the shape sheet, and so it's well worth becoming familiar with what's there. So now we've got an understanding of the object model and how to interact with it, I'm going to move on to a key area in Visio, and that's event handling. Like most events, Visio offers you a wide range of events throughout the object model, enabling your code to react to various changes in the application made by the user or other code. There are a number of aspects to handling events in Visio, and I'm going to try and move through them in order of complexity, or maybe I should say from the simple through to the more involved. The range of events that Visio exposes go from things that deal with high-level objects like app activated and document opened, through mid-level object events such as page and shape added, and all the way down to cell-level events like formula changed and cell changed. Although there are a number of ways of listening to events, fundamentally what's happening is this. You have some code, which might be in VBA in the document or perhaps in a Visio add-in, and you want to react to some event that occurs within Visio. On the Visio side of things, there are two objects. There's the subject of the event, i.e. the thing that the event happened to or in, and the source, which is the object that reports the event. By listening for a particular event on the source object, your client code can then handle that event and take whatever actions that you decide you want to carry out. The way in which this happens depends on the method that you use to hook up the source, and I'll add to this diagram as we explore the options. The source object can be one of a number of objects, and the point at which you decide to listen determines the scope of the events that you can react to. This can also have an impact on performance. For example, here's a model of an application with two documents and multiple pages. If you start listening to the formula changed event using the application as the source, then your code will have to deal with all formula changes in all cells, in all shapes, in all pages, and in all documents that are open in the application. And that's a lot of event firing. A better strategy is to narrow your scope by focusing on a target document or page to limit the number of events that you have to deal with and thereby improving performance. Scoping will often depend on the type of project you're building. Chris Hopkins from Microsoft and former Visio team member has a blog post where he makes a nice distinction between typical add-in projects as being either a tool or a solution. He describes a tool as independent of templates or a particular set of shapes, and a solution, by contrast, as depending on one or more templates and associated sets of shapes. So in terms of scoping, for a solution you might begin by listening at application level to document opened and document created events, to determine if a particular document is based on one of your solution templates, and then if it is, narrowing down any further listening to that particular document. For tools, your strategy is more likely to be application-wide, but even then, you might only start listening to formula changed events, for example, if the active window is of a particular type. Clearly the options for tools are pretty broad, but the principle of keeping your event listening as narrow as reasonably possible still stands. So now you know where to listen for events, let's look at the options for how you handle events. Before I start, let's just get a quick overview of all the working parts. There's a selection of event cells in the shapesheet that allow you to respond to certain events directly within the shapesheet. In VBA, there's the ThisDocument class module that comes pre-wired with all of the document events. In VB-based languages, there's the WithEvents modifier, which allows you to declare an object variable including its event interface, and then provide handlers for each of the events exposed by that object. In .NET, you can hook up to events using delegate event methods. These are methods exposed by the Visio primary interoper assembly that allow you to reference a handler method of your own creation. And finally, Visio also provides you with its own event objects. Each source object has an event list property, which is a collection that you can add event objects to. An event object takes one of two actions, and this is determined by the method that you use on the event list to create it. The eventlist.add method enables you to run an add-on, while the addAdvise method allows you to provide your own object that will be advised or notified that an event has occurred. So that's the main event handling techniques, and I'm going to look at each of these in more detail in a second. But first, I'd like to highlight a few important areas of event functionality that support these main techniques. As I mentioned, narrowing down the listening scope is an important consideration. To help with this, Visio provides a method of event filtering that can be applied to event objects created using the addAdvise method. The technique allows you to filter the events that will be received by your code based on an object's type, such as the group, master, or document, on cell ranges, using section, row, column indices to set up upper and lower limits, on command IDs, for example to catch cut and paste operations, or when the connector or text block tools are selected, and on a selection of mouse events, for example to only receive drop events, but not the begin, enter, and leave ones. Persistent events are a mechanism that allows you to store an event that runs an add-on in the file. So for example, that it's automatically wired up and ready to fire the next time the file is opened, with no further code required. There's only a handful of events that are actually persistable, such as document opened and master added, but the main point is that they relieve you from permanently listening to events across all documents, allowing the target add-on to be run only when required. Marker events are an application event that are designed to allow your code to place markers into the mainstream of Visio events. The event allows you to set a context string, and this enables you to determine which events were caused by your code and which ones generated by normal Visio operations. For example, if your code had a number of cell changes to perform on a shape, you might start your operations by creating an event marker and then creating another one when you completed your work. That way any other event listening could ignore events fired by your code operations and only respond to events fired during normal operation. The way that you add a marker event is to use the queueMarkerEvent method on the application object. Marker events don't have to be used simply to top and tail your operations, however. In 2002, the queueMarkerEvent add-on was introduced and extended what marker events could be used for. If you remember, persistent events can only call add-ons, not COM or Visto add-ins. So the queueMarkerEvent add-on allows you to fire a persisted event that your add-in can be listening for and respond to. This extends to the shapesheet, again where you can't call the add-in directly, but you can call the queueMarkerEvent add-on using run add-on with args shapesheet function, and since 2002 this has been wrapped up into its own standalone shapesheet function called, you guessed it, queueMarkerEvent. So the key takeaway for all of the aspects of queueMarkerEvent, the application method, the add-on, and the shapesheet function, is that it allows an add-in to be run almost directly, and most significantly directly from the shapesheet. So that's the conceptual side of event handling in Visio. Now let's take a look at integrating those event types into the coffee store example to see the code in more detail. Here's the same coffee store layout that we looked at when exploring the object model. You can still right-click on a table shape and add a chair, but what I want to deal with now is what happens when a chair is deleted. The behaviour I'm looking for is to have Visio automatically rearrange the remaining chairs. Let's have a look at the code. You might remember that the chairs are only placed relative to a target table, but have no relationship with that table. So what I've done is declared a variable referencing the application, and most importantly using the withEvents keyword. WithEvents offers most, but not all events that can be accessed using addAdvise. For example, before shape deleted and shapes deleted, are available at both application and document level using add-advise, but only at application level with events. Given that I'm going to be listening to before shape delete events across all open documents, I need to ensure that the document where the event occurred is the right one, and so on that basis I've already added a GUID to a user cell in the templates document shapesheet, which I can then check for within the handler. So bear in mind that all this code is housed in the stencil document and not the template or the resulting drawing document. But broadly, the basic flow happens like this. I listen for the document opened event of the stencil itself, and when it's fired, I create a new collection to hold the table shapes that will be rearranged, and also set the application variable. When a shape is deleted, the before shape delete event fires, and once we're happy that we're talking to the right document, we can start the work of setting the right table. I only want to react to shapes derived from my chairmaster, and if that check returns true, then we can move on to carry out the same spatial search that we did when adding a chair. Assuming a table has been found, it's added to the collection, and we now just need to wait for Visio to process its own event queue while the shapes are actually deleted. In fact, Visio provides you with a special event to notify you when it's ready, and that's no events pending. From here we can wait until Visio is ready, and when it is, the final rearrange is called. Here we recreate the selection once again, arrange using the same radial layout, and finally remove the table from the Tables to Arrange collection. As you can see, using with events is a fairly straightforward method of event handling. However, this ease of implementation comes at a cost. Let's come back to this conceptual diagram of events. As you've seen, Visio maintains a collection of events for each source object. This collection, or event list, is initially empty, and if you use the add-advise method, then you get per-item control over each event that you want to create. Using with events, however, even though you might only be handling a single event, your referenced object is receiving events for the whole spectrum available for that object. And if you inspect the event list of your reference source object, you'll find that it's fully populated, whether you wanted that or not. Using delegate-based event handling, which we'll look at in a second, also suffers from the same problem. The best solution then is to use add-advise. Using this method, you get to define your own class that Visio will send a notification to that an event has occurred. You start off by getting a reference to your target source object and calling add-advise on its event list. As part of this call, you pass a reference to an instance of your event sync class, and this is what Visio uses to fire a notification to. So now we've got the blocks in place, let's move on to an equivalent Visto solution and have a look at both delegate-based events and using add-advise plus our own event sync to catch other events. So here we are back in the same coffee store template that we saw earlier. This drawing supports adding, deleting and rearranging chairs just as before, but this time the stencil is completely code-free and all of the action takes place in a Visto add-in. While we're in Visio, I'll take a look at how the add chair functionality is invoked. Our previous VBA solution relied on the call this shapesheet function, but now we're in an add-in, we can use the QMarker event function instead. Using this function, we get to pass a context string to the event, and I'm including both the ID of the solution and the command that I want to execute. If we now move over to Visual Studio, you can see there are a number of things that we've got to wire up in the add-in as it's loaded. First of all, I create a small parser class so that I can ingest the context string in a meaningful way. Once that's ready, I then wire up some initial event listening using delegate events. Notice quickly that in the first line I've included the full delegate name that the Visio API gives you so that you can see what's happening. It's marked as redundant because the compiler infers the type and allows you to simply add the reference to the handler method. So document created will fire when a new drawing is created from a template, while document opened will fire when an existing drawing document is opened. In either case, I then check if the document that fired the event is based on this solution, and if it is, then I add it to the collection of watch documents. Also, If it's the first item in the collection, then I kick off listening for marker events on the application object. In fact, I wrap the watch documents into a separate class named docWrapper, and it's here that I wire up the further listening for events on the document itself. Let's head over to the docWrapper class, where you can see that the remaining event listening is connected up during the class's construction. This time I'm using the addAdvise method rather than the delegate events. Normally you'd only choose one method, but for demonstration purposes I wanted to show both techniques. With addAdvise, I get hold of the event list object of the document, create a new event sync class, and then call the addAdvise method on the event list, passing in the event code and the instance of the event sync. The addAdvise method returns an event object that I hold onto within a list to maintain a reference. So at this stage everything is wired up and we're just waiting for somebody to add or delete a chair. In the case of adding a chair, you'll remember that the queueMarker event shapesheet function is fired, and since I'm now listening to marker events, it gets handled in this method. Given that there may be a lot of marker events being fired, and not just from this add-in, the first thing to do is to check that the event is meant for this solution. If it is, then we can head off and process the context string that we've received. I'm not going to look at this now, as I really want to stay focused on the event side of things, and the code is basically a C# version of the same VBA code that you saw when we looked at the with events example. If, on the other hand, a shape is deleted, then our event sync class will be notified by Visio about the events that we've subscribed to. So let's finally look at the sync and the visEventProc method that's defined by the interface. In this case, we check the incoming event code, and if it's the before selection delete one, then we add the selection to a queue, and then we process the table shapes in that queue when Visio fires the no events pending event. You can see the two methods that do this work in the Furniture Manager class. One to get the table associated with the chair that's about to be deleted, and one for rearranging the remaining chairs once Visio has actually finished deleting the target chair. The solution is tailed off by removing a watched document from the collection when a document is closed, and if it's the final one in our collection, then we can also stop listening for marker events. And last but not least, the thisaddin shutdown method calls our associated disconnect method to unsubscribe the remaining delegate events when the add-in is unloaded. And bear in mind that this may be prior to the host application being closed. So that completes our look at events in Visio. As you've seen, there's a number of options available, and the key things to watch out for are the level at which you listen to events, try to narrow your scope whenever possible, and the method that you hook up to Visio. Favour addAdvise and event sync notification over chatty with events. So you've built your new solution stencil and template. You've chosen your coding model and created an assembly. Now it's time to get all of those elements onto the end user's machine. Depending on whether you're creating an add-on or add-in, you can think of a solution as comprising of two basic parts, the code and the content. For the code deployment, your choices are to wrap everything into a Windows installer MSI, or to use Click Once. I'm going to come back to these two options in a minute, but first let's look at what happens from the content side. Visio has two methods of finding files that you provide and presenting them within the UI. The first is path discovery, and the second is publishing. If you open up the Options dialog and look under the Advanced tab, you'll find the File Locations button. Clicking this reveals a further dialog that shows a number of folder paths to various file types. This forms the basis of the original method of providing Visio with a number of places to search the file system for stencils, templates and help files, and add-ons. On each startup, Visio surveys those file locations in order to make them available via the UI. This path discovery system remains today, however Visio 2003 introduced a new method called publishing. This newer technique involved publishing all of the details of your content files out to the registry. Visio then surveys the registry and builds a cache of content details, which relieves it from having to survey the file system or the registry every time it's launched. It will only rescan the registry and update the cached version when a particular value changes, or if it's unable to find a cache file. I should point out that although I said earlier that you can think of the split as being between content and code, in fact add-ons are also discovered using path discovery or publishing. This is in contrast to add-ins, which only use another key in the registry to determine how they're loaded. Aside from being able to cache content file locations, publishing offers a number of other benefits. It allows add-ons to be trusted by default. It lets you choose where the files are located, but doesn't force you to use that location in the UI, which is not the case for path discovery. It provides support for multi-language file versions, both specific and fallback, and using the MSI route, you benefit from Windows installer features such as resiliency, which automatically repairs your files as required, and the simple install and uninstall experience via Windows programs and features. If you're not familiar with MSI files, they're basically an installation package which, apart from containing all of the assets for the installation, includes a database which describes what all of the parts are and the steps required to carry out the installation. One of the tables in the database is called the Published Components table, and it's here that a list of any stencils, templates, add-ons and help files are added. Visio has a set of known GUIDs that it uses to uniquely identify each content type, and along with a range of additional settings such as locale ID, menu path and alternate file names, gives you everything you need to publish your content so that it appears correctly in the UI. You can add all of these settings manually to the MSI using a tool like Orca, which is part of the Windows SDK, or as part of the MSI creation using Wix. However, a simpler method is to use the tool that's part of the Visio SDK, called the Visio Solution Publishing tool. This gives you a friendly UI to edit all of the details and handles the integration into the MSI. The process for using the tool is as follows. You add your content files to the setup project, you build the project to create the MSI, and finally you open the MSI in the publishing tool. So for example, here's a Visto add-in project with an associated setup project. I've referenced the stencil and template that I want to install within the setup project under a folder that I've decided to name Visio Content. If I build the project, an MSI will be generated, and I can then open the publishing tool and point it at the newly created package. Here you can see that I've added a custom menu path, and if I open up the template item, you can also see all of the properties that are available to be set. With all of that in place, I can install the MSI and see my new template created as part of the standard UI in Visio under its predefined folder. Aside from the UI, the Solution Publishing tool also has a command line interface allowing you to integrate the tool into your build process. And if you're interested in this, then you should have a look in the help file that comes with the tool. So that's the two methods of surfacing your content within the Visio UI. And I'm now going to come back to how you choose your deployment model. I'm not going to get into a conversation on the relative benefits of Click Once versus Windows Installer. I really want to look at this from a Visio perspective, and I'm going to simplify that down to your requirements for the stencil and template files that we've just talked about, and whether you need your solution to be deployed per user or to all users. You can see that the MSI route allows for all options, while Click Once only supports a more limited set. The Click Once limitations are due to the fact that it cannot write to the local machine hive of the registry, and this is a requirement for allowing your add-in to run for all users, and also for publishing your Visio content. If you don't have any content to deploy, then Click Once is a very viable option. It's also an option if you're happy with the path discovery method and are prepared to do a little more work by editing your deployment manifest to add a post-deployment action. This requires the manifest to be re-signed using Mage, and you can find an example script that automates all of these steps in the Visio SDK. Just bear in mind that out of the box, a Visto add-in deployed using Click Once doesn't support additional files in the same way that a standalone exe-click-once deployment does. Overall, you should really consider click-once as the default deployment mechanism, unless you have particular needs that sit outside of this, such as deploying to all users or the publishing caveats that I've highlighted. So that completes this flyby course on Visio. As I said at the beginning, this has been focused on the concepts rather than the details, so I hope you're now armed with a complete picture of how Visio works and have a structure for where to store the detailed information in the various docs and content out there. Thanks for watching.